Here's a problem out of our WAMAP assignment. Outside temperature over a day can be modeled as a sinusoidal function. Suppose you know the high temperature for the day is 79 degrees and the low temperature of 51 degrees occurs at 4 a.m. Assuming T is the number of hours since midnight, find an equation for the temperature, capital D, in terms of T. So we started off in function notation, D as a function of T. And so it says temperature stand as D. Why you would use D to stand for temperature, I'm not exactly sure, but that's what the problem gave us. So D is a function of time. And so I took a screenshot of that. Here's the same problem. And I made a graph ahead of time because I thought that would probably be a helpful way to come up with our equation. You don't need a graph, it is not a requirement, but illustrations are good. So outside temperature over a day can be modeled as a sinusoidal function. So either sine or cosine, either of those is referred to as sinusoidal. And I know the high temperature is 79. So I'm going to go ahead and throw a guideline on here at 79. The low temperature of 51 occurs at 4 in the morning. So here's 51. I'm going to label those because it'll be a little bit hard to read that from the graph. So this is 79. This one is 51. So in order to find the amplitude, also to find where the midline is, I need to find out what would be the middle temperature, halfway between 51 and 79. So I got a maximum and a minimum, but I need the middle. The difference is 28 degrees between 79 minus 51, 28. Half that is 14. And so from the minimum, I'm going to go up another 14 degrees to find the minimum. That puts me at 65. Okay, that's my midline. So I know the vertical shift 65. That's the midline. Also, at this point, I know the amplitude. That is the distance from the midline up to the maximum or from the midline down to the minimum. I just used that number to find the midline. So the total difference was 28. I cut that in half to get 14. That difference of 14, that's the amplitude. And now I'm going to start drawing things. To get any more of the equation, let's see. So I said VS for vertical shift in our equation. Vertical shift is written as a D. So just for the sake of clarity, that is my D value, or vertical shift. So other things in the equation, whether I'm using sine or cosine, has not been decided yet, but I've got the amplitude. I still need to find a K, a phase shift, and I've got the D. So let's start plotting some points so that we can more easily visualize what in the world is going on here. The low temperature occurs at 4 a.m. So my graph started at 0 hours, and this is hours after midnight. So military time would pretty much mean the same thing as the way my graph is labeled. Midnight is going to be hour 0, and then 1, 2, 3, 4. So at 4 a.m., that's 4 hours after midnight. That's the minimum. And then the next minimum would happen 24 hours later at 4 a.m. the next day, which will not fit on my graph, but I do know that a day has 24 hours. So the period is 24 hours. And I can use the period now to find the K value that's going to go into my equation. I guess I didn't actually need to write anything on the graph at this point. 2 pi divided by 24, period is 24, and then reduce that, so I'm going to get pi over 12. So that's my K. So I've got D, K, and A. I still need to get the phase shift and decide whether I'm going to do sine or cosine. Okay, so to draw points on the graph, if I'm thinking about our 5 key points, I know that the 5 key points, whether it's sine or cosine, each of those 5 key points happen 1/4 of the way through the period. If the period is 24 hours, 1/4 of the period is 6 hours. So every 6 hours, I'm going to hit a key point. So my first dot I drew on the graph is at the minimum. I'm going to come to the next key point will be at a midline at 6 hours later. So 4 plus 6 is 10. So at hour 10, it'll be at the midline. 6 hours after that, 10 plus 6 is 16. It's going to be a maximum. 6 more hours will put me at hour 22. That is the minimum. And then to get any more key points, I would need to have a larger graph. So at hour 28, which is not, I don't have that labeled, 28, I'd be back to the minimum. Or at the left edge of the graph, I would be back at the midline 6 hours prior to that first dot. So it'd be like hour -2, which I probably could fit on my graph. It'd be like right here. And then I can draw over there. All right. So I got some options for phase shift and whether I'm going to do sine or cosine. So one option is I could choose to do a sine graph. Sine starts at the midline, so I could start right here at the midline going up. And that would tell me, if I were going to do that, I would use a sine for my equation, and the phase shift is right by 10 hours. Okay, that's one option. Or I could decide I want to do a cosine graph. Cosine starts at the maximum, so that's going to be right here, and then it goes forward. So I could use cosine, and then I would need a phase shift of 16. I have some other options as well. I could decide that I want to, for some reason, I want to do a negative cosine because I want to have the smallest phase shift possible. So negative cosine, if I make the amplitude negative, is going to start at the minimum. So that'd be right here at that minimum point. So I could do a negative amplitude to reflect my cosine graph so that it starts at the minimum, and then I would still need a phase shift of 4 hours to get start there at the pink or magenta dot. And then there's an infinite number of possibilities here, but just to throw one more idea out there, we could decide to start at the very first dot I drew on the graph, which is at -2. In order to make this work, my phase shift is going to go left 2, and then this would be a negative amplitude sine graph, starting at the minimum but going down to the minimum next. So I could do a negative amplitude sine graph with a phase shift of left 2. Any of those is going to be correct. WAMAP is going to handle any of those. They're all, the computer doesn't care which one you use. So really it's a question of what you think is going to be easiest as far as making sense to you. So let's just do the positive amplitude ones. Let's do sine. And so that's going to amplitude, that has a positive amplitude, phase shift of +10. So if I did sine, my amplitude was 14. Sine, I'm going to use square brackets here. The k value is pi/12. I used the period to get that. And then I'm going to start another set of parentheses. I'm going to change the variable to t, since this is a graph based on time rather than using the theta for radians. You could use theta if you want. It doesn't make any difference. Well, to WAMAP, it makes a difference. The directions told you to use t, and so you have to use t. If you were not on WAMAP, you could use whatever variable you wanted. And then a phase shift. So we said we're going to do that point as our start for sine. And the phase shift there is to the right by 10 hours. And to move to the right 10, I need to put -10 in the equation. So it's always the opposite direction of what we think it ought to be. That's like the world's worst 10. 10, close those parentheses. And then our vertical shift, which we said is 65. Whoops, that's this color. Our phase shift is supposed to be this color. I got the parentheses too, that's fine. Okay, so there's one possible answer. That is correct. We could also do, instead, we could have done cosine. And so let's look at that real fast. Cosine would start at the maximum, and so that's going to start right here. It's going to give me a different phase shift. That's the only thing that'll be different. I'm going to write cosine, and the phase shift will be different. So for cosine, I'll need a phase shift of 16 hours to the right. So in the equation, that'll be minus 16. So that will look like this. So, whoops, erasing. So we're going to change this to cosine, and we're going to change this one to 16. And then there are other possible answers that are correct. I'm not going to go through every single possible answer. Whoops. Oh my gosh. Close all the parentheses. Otherwise, that will cause a problem. So either of those will work, as well as some other options.